Okay. Curves in space and their tangents. Well, we'll go through just a couple. I don't think this is a big section, so we'll just quickly go through it. Yeah, long description, so just, I think, 5 problems or so, a few more maybe. What about just giving a quick rundown of 2 or 3 types of problems. But yeah, for 1 and 3, so for 2 problems, we're going to do RT is the position of a particle in the xy plane at time t. Find an equation in x and y whose graph is the path of the particle. Then find the particle's velocity and acceleration vectors at the given value of t. So yeah, it's kind of wordy. But RT is equal to t plus 1i plus t squared minus 1j. T equals 1. And these on xy planes, just I and j are used. In general, basically RT is equal to xi plus yj, kind of a general format. So x equals t plus 1 and y equals t squared minus 1 here. And that means that t equals x minus 1 and y, so, that can be plugged in basically. X minus 1 squared minus 1. That's x squared minus 2x plus 1 minus 1, and ends up with x squared minus 2x. That's the equation that's part of this path of the particle. Anyway, vector v is equal to basically the velocity vector is dr dt, so it's the derivative of r with respect to t, time. And it's the derivative of the parts. I'll try to go over this more in detail as the next one was to work. So derivative of t, you can basically do the individual parts. It's just like normal derivatives, just with individual parts of I, j, and k. So t plus 1, t plus 1i, that becomes just 1 times I, so I. Plus 2t, because t squared minus 1, you just have 2t as derivative. And acceleration is the derivative of this, of the v, of the velocity vector, with respect to time. So 1 becomes 0, because that's the derivative of a constant is 0, and 2t, the derivative of that is 2. So acceleration is going to be constant for this type of particle. It's basically what it's saying. But no, at t equals 1 though, v equals I plus 2j, and a equals, acceleration vector is 2j. Pretty good. This one's a little bit more complicated. But so we have another one was eti plus 2/9 times e to the 2tj. T equals L and 3 is what we're going to evaluate it at. The easiest way is to do a direct substitution early on, so you don't have to worry about messing with logs too much here, at least when you're trying to figure out a way to get x into y. So x equals et, y equals 2/9 times e to the 2t. So y is equal to 2/9 times et squared. That's how it works. E to the 2 times something would mean that it's everything in that squared, the whole thing squared. And furthermore, it's et, x is et, so this is x squared. So y equals 2/9 times x squared is the equation in xy for the particle's path. So v at t is equal to, I put the primes here to show it. It's et prime, so the derivative of et, and the derivative of 2/9 times e to the 2t. Derivative of e to the t power raised to t is just e to the t, because it's e to the t times 1 technically, since it's the derivative of t is 1. But that's a simple idea. Same with this, e to the 2t times 2/9. 2/9 is constant, so you just take the derivative of that apart basically, because e to the 2t is not constant. And you pull out the 2 and it's e to the tt still. Okay, so 4/9 t to the 2tj is what velocity is, e to the ti plus 4/9 t to the 2tj. And same thing with acceleration, you just pull down another 2, and you get 8/9 to e to the 2tj and e to the ti acceleration vector. And at t equals ln 3, you do some more simplification. You plug it in basically and try to simplify. E to the ln 3I plus 4 ninths to e to the 2 times ln 3. Just keep it simple, make sure no math gets messed up. But now I'm trying to do technical. It's e to the ln 3 squared. E to the ln of something will be just, 3 will be just 3 squared. Then 3i, a to the ln 3 is just 3. So it's 3i. You end up simplifying down to 3i plus 4j basically, and then that's the velocity at that point at ln 3. Finalize this, you have acceleration. Acceleration at ln 3, and it's 3i again because of course they have e to the t as a term. 8 ninths, yeah, it's 8 versus 4j, because 4 ninths times 9 and n versus 8 ninths times 9 basically, because e to the ln 3 basically squared will be the same thing. Yeah, you just have to know your basic properties of exponentials and logarithms, just basic stuff like that. No biggie. For the next two problems, 9-11, we have position of a particle in space at time t again. You want to find particles' velocity and acceleration vectors, and find particle speed and direction of motion at the given value of t. Write the on a right velocity at that time, use the product as the product of its speed and direction. Trying to be fancy, but yeah. If you took physics, you kind of have an idea already of what this stuff is, though. This is more of a kind of introduction to this idea of using vectors from some applications. And with calc, of course. Okay, so we have this t plus 1i plus t squared minus 1j plus 2tk. T equals 1 is what we have to evaluate it at. So we get and velocity vector and acceleration vector are easily found by taking derivatives. So in the end, derivative t plus 1 is just 1. T squared minus 1 is 2. And 2t is 2. That's what velocity vector is with I, j, and k. And acceleration will be, well, it'll just be 2j this time. This is like a very similar to the first one in your specs. Just having 2j be the acceleration no matter what time t is. And v of 1 is equal to I plus 2j plus 2k. We'll just say that right now so we can get that out. So we need to know that to be able to solve for speed and velocity and stuff in this direction. So just 2 times t is the only thing that's changing here. So I plus 2j plus 2k. And at t equals 1 speed, therefore is the, v of t. This is like v of 1 basically. But speed is just a magnitude of the velocity function at a current value. But it's 1 squared plus 2 squared plus 2 squared, which you end up with, the square root of that, which is square root of 9 equals 3. Direction is similar to before. See, these first few sections all come in play. You get the first part of this course down, this part right here will be not too bad. 1/3 I plus 2/3 j plus 2/3 k, because it's divided by all three, This is direction, you have speed direction. I plus 2j plus 2k comes from here. And velocity of the particle at t equals 1 as product of speed and direction is the v of 1 equals 3 times this expression from here. The magnitude direction. Or speed, magnitude is speed here. And 11 is the same thing, just a little bit more complicated. It's cosine and sine. Hopefully you didn't forget how to do derivatives of that. T equals pi halves is the point to evaluate because we're using cosine and sine, so certain parts of unit circle come into play. If you want nice numbers, that is. Velocity function is just negative 2 sine t, because that's the derivative of 2 cosine t. You know, the derivative of cosine t is negative sine t. Negative 2 sine t is derivative of 2 cosine t. And 3 sine t becomes 3 cosine t, and 4t becomes 4. So an acceleration is just another derivative of what velocity is. So it's negative 2 cosine t plus, I plus negative 3 sine t, because 3 cosine t's derivative is negative 3 sine t, and negative 2 sine t's derivative is negative 2 cosine t. At t equals pi halves, the speed is again just v of pi halves, magnitude, which is negative 2 sine pi halves squared plus 3 cosine pi halves squared plus 4 squared. Which you get basically negative 2 squared plus 0 squared plus 16 squared. 4 squared, which is 16. Negative 2, 0, and 6, and 4. We'll use those as for directions, but you get square root of 20, which is equal to 2 square root of 5, so that's your speed. And direction is v of pi halves divided by magnitude of v of pi halves. So 2 square root of 5, we already know the denominator. And negative 2i plus 0j plus 4k, and negative 2 from negative 2 sine pi halves, which is negative 2, because sine of pi halves is 1. Cosine of pi halves is 0. That's what it becomes, the direction is negative 1 divided by square root of 5i plus 2 square root of 5i divided by square root of 5. k, And then the product is 2 square root of 5 times negative 1 divided by square root of 5i plus 2 divided by square root of 5k. And one last problem, there's some other ones you can do with this, but let's just end it with this one for this section, because it's supposed to be a short period of time you spend on this, not a lot. Find the angle between the velocity and acceleration vectors at time t equals 0 for this value of r, given the position function. Rt equals 3t plus 1i plus square root of 3 times tj plus t squared k. So velocity is 3i plus square root of 3j plus 2tk. Velocity at 0 is 3i plus square root of 3j plus 0k, because it's only wants t in it, so it's 0. Acceleration is 0i plus 0j plus 2k. Which means that the acceleration is 2k, and a of 0 is 2k. Because that's how this works here. So we have pretty simple equation, and we use from cosine to theta equals u dot v, magnitude of v, magnitude of u, This thing we have cosine to theta, if we want the angle. So it's inverse cosine of v0 times a of 0, the dot product of them, by v of 0 is magnitude and a of 0 magnitude. And simply put, it's easy to find these magnitudes. Square root of 3 squared plus square root of 3 squared, which equals 9, square root of 9 plus 3, which equals square root of 12. And a of 0 is just square root of 2 squared, which equals 2. And then, but it's very simple. The dot product is 3 times 0 plus square root of 3 times 0 plus 0 times 2, so it's just 0. So in the end, it's going to be cosine inverse of 0, which means that theta equals pi halves. Because pretty much cosine is 0 when cosine equals 0 when theta equals pi halves. And that'll be all.